Now we will learn how the basic ccna communication established between server and PC. Now we will see how ccna works while accessing a web server for a PC. Step-by-step breakdown of the ccna process. First, the client web browser sends a ccna message to the server web server to initiate a connection request. This message contains a random sequence number, which is used to ensure the reliability and order of the data transmission. Then the server web server receives the ccna message and sends back an ccna message to the client web browser. This message contains an acknowledgement of the sequence number sent by the client and a random sequence number generated by the server. The client web browser receives the ccna message and sends back an ACK message to the server web server. This message acknowledges the sequence number sent by the server. The connection is now established, and data can be transmitted between the client web browser and the server web server over the connection. Now we will learn about TCP Ip. TCP Ip. TCP stands for Transmission Control Protocol, and IP stands Internet Protocol. TCP developed by the Department of Defense. It is a suite of communication protocols used to interconnect network devices on the Internet and specifies how data is exchanged. TCP is responsible for breaking the data into packets and transmitting. IP ensures the packet reachability to destination. TCP IP provides a standard for communication across different types of systems and networks, which allows them to communicate with each other seamlessly. The protocol suite includes several other protocols such as HTTP, FTP, SMTP, and Telnet, which are used for specific purposes such as web browsing, file transfer, email, and remote access. TCP IP is an open protocol. It is vulnerable to attacks from hackers where they can intercept and modify data packets and transmit across the network. To address this issue later came SSL TLS secure protocols. TCP IP have 4 layers. Each layer is responsible for a different aspect of communication. First, network access layer. Second, internet layer. Third, transport layer. And last, application layer. In details, network access layer. The network access layer is responsible for the physical transmission of data over the network. It defines how data is transmitted over the physical network medium, such as Ethernet or Wi-Fi. The protocols used at this layer include Ethernet, Wi-Fi, and PPP, point-to-point protocol. Next, internet layer. The internet layer is responsible for addressing, routing, and fragmenting packets. It is responsible for getting packets from the source to the destination. It defines logical transmission of packets in the network. The protocols used at this layer include IP, Internet Protocol, ICMP, Internet Control Message Protocol, and ARP, Address Resolution Protocol. Transport layer. The transport layer provides end-to-end communication between devices. It is responsible for ensuring that data is transmitted reliably and without errors. The protocols used at this layer include TCP and UDP, User Datagram Protocol. It deals with issues like establishing secure end-to-end communication. Application layer. The application layer is the highest layer in the TCP IP stack. It provides interfaces to applications that need to communicate over the network, such as web browsers, email clients, and file transfer utilities. It controls user interface arrangement. The protocols used at this layer include HTTP, FTP, SMTP, and Telnet. Now we will learn about OSI layers. First, physical layer. This layer is responsible for transmitting raw bits over the physical network medium, such as copper wires, fiber optics, or wireless signals. Second, data link layer. This layer is responsible for transmitting data frames over a physical link between 2 devices. It provides error detection and correction and ensures that data is transmitted reliably and efficiently. Third, network layer. This layer is responsible for routing packets between different networks. It provides logical addressing and packet forwarding functions. Fourth, transport layer. This layer is responsible for providing end-to-end communication between devices. It ensures that data is transmitted reliably and without errors, and provides flow control and congestion avoidance mechanisms. Fifth, session layer. This layer is responsible for establishing and managing sessions between applications running on different devices. It provides mechanisms for starting, maintaining, and ending sessions, and for recovering from session failures. Sixth, presentation layer. This layer is responsible for translating data between different formats used by different applications. It provides functions such as data encryption, compression, and decryption. Seventh layer is application layer. This layer is responsible for providing interfaces for applications that need to communicate over the network. It includes protocols such as HTTP, FTP, SMTP, and Telnet.